Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra, the Math 8 edition. I'm your host, Mr. Takeda, and I'm going to teach you some math right now. This is lesson 3.2 on angles of triangles. So if you're ready, let's go. So we're going to start with some vocabulary again, but this time they're words we've already seen. Now, previously we looked at the words interior angles and exterior angles in the context of transversals intersecting parallel lines. But in this case, we're going to use these terms to refer to angles of a triangle. The uh, the definition is kind of built into the terms. Interior angles, again, interior means inside. So interior angles are the ones inside the triangle, and there will be three of them. Exterior angles are the ones outside. They are going to be adjacent to or next to interior angles. So there are going to be 6 exterior angles formed. All right. So so keep that idea in mind. We have exterior angles created with lines that intersect, not just like a regular triangle, but when lines intersect. So we're talking about lines here forming triangles. Okay, so let's take a look at our first big idea here. And I think this is something that we already know, is that the sum of the interior angles, the sum of the measures of the interior angle of a triangle equal 180 degrees. So you can see in the diagram here, they have one angle labeled X, one labeled Y, one labeled Z, and they're telling us that when you add those together, the sum of those 3 angles equals 180 degrees. Now this is something that we can use to answer some questions about triangles. Let's see what we have here as an example here. So here's our first examples. Find the value of X. So we can see in this triangle here, we have measures of 2 angles given to us, but a third is unknown, right? So what we can do, since the sum of all the angles equals 180, I can write an algebraic equation that shows us that the sum, 32 and 48, plus X, that's our unknown, equals 180 degrees. How am I going to solve this? Go ahead and simplify here. I'm going to collect these terms here, add them together. 2 and 8 is 10, so 0 carry the 1. 3 and 4 is 7, plus the 1 is 8. So 80 plus X equals 180. Subtracting 80 from both sides, X equals 100. That's the value of X. On the second example here, we have a couple things happening. So first of all, they don't give us any measurements except, well, they actually give us one. This little box, kind of this little square indicator here, indicates that this is a right angle, which means this is 90 degrees. So my equation here is going to be 90 plus X plus 28. Now I'm going to put that in parentheses for now, plus X equals 180. So 90 plus X plus 28 plus X. Okay, the reason I want to put this in parentheses now, because sometimes, especially when you're dealing with these types of equations, if there's a minus out here, you have to change what's in here when you get rid of the parentheses. But since this is just a plus, I can essentially rewrite this without the parentheses, which means I'm now free to combine like terms. I'm going to do 2 steps at once here. I'm going to add the X and the X, and I'm going to get 2X. I'm going to add the 90 and the 28 and get 118. And that's going to equal 180. Excuse me. I don't know if you heard. I just sneezed. I don't think I got it in time. Okay, so then we'll subtract 118 from both sides. That's going to leave 2x equals 10 minus 8 is 2. That makes this a 7. 7 minus 1 is 6. So 2x equals 62. Dividing both sides by 2, x equals 31. Right? So that one's a little more complicated, but we know how to solve these types of equations based on what we did in chapter 1. Now let's look at exterior angles. All right? Exterior angles. Let's look at the words first. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Let's talk about the word non-adjacent. Adjacent means next to. So non-adjacent means not next to. So this exterior angle is going to be adjacent to one angle, and the other two angles will be non-adjacent. This exterior angle will be next to one of the angles, so the other two will be called non-adjacent because it's not next to that one. But here's the relationship, that the measure of this exterior angle is equal to the sum of the others. So why is that? And this kind of makes sense if you think about it. I'm going to call the unlabeled one here A. So I know x plus y plus A equals 180 degrees. And I know A plus Z, because they're supplementary angles, also equals 180 degrees. So since they're both equal to 180 degrees, I can write a new equation that says since they're both equal to 180, that means they're equal to each other. I'm going to cancel things on both sides that are the same. So look, x plus y equals z. All right, so this all kind of makes sense. The measure out here is equal to these, the sum of these other two. Let's take a look at an example. All right, so we want to find the sum of the exterior angle. In this case, this is x. Well, I can add the sum of the two non-adjacent interior angles to get that. So 36 plus 72 equals x. So let's see, 6 plus 2 is 8. 3 plus 7 is 10. So 108 equals x. So the measure of that angle is 108 degrees. For the second example, it's going to set up basically the same, but the solving the equation is going to be have an extra couple of steps in it. So the two non-adjacent angles here would be 80 degrees plus a minus 5. And that's going to be equal to 2a. So simplifying the left side here, 80 minus 5 is 75. So 75 plus a will equal 2a. Then trying to get my variables onto one side and my numbers on the other, I'm going to subtract a from the left and from the right. On the left it cancels, leaving me just 75 on the left. On the right, 2a minus a is just 1a. So a is 75. But that's not what we're being asked to find. We're being asked to find the measure of the exterior angle. The exterior angle is 2a. So in order to find that, I have to substitute the a with 75. And that's going to result in 150 degrees. Okay, that's it. There's a third example. It's just kind of a word problem using a diagram that really sets up like example 1. So we'll do that one in class. All right, so thanks a lot and have a great rest of your day.